Hey Ram, remember when we were talking about the basics of electrical engineering? I think it's a good time to dig deeper into voltage and current laws. They're like the building blocks of understanding circuits.
Absolutely. Voltage and current are at the heart of electrical systems. Let's start with Ohm's law. It's a fundamental principle that relates voltage, current, and resistance in a circuit.
Right. Ohm's law states that the current flowing through a conductor is directly proportional to the voltage across it, and inversely proportional to its resistance. The equation is I equals V/R, where I is the current in amperes, V is the voltage in volts, and R is the resistance in ohms.
Exactly. This law is incredibly useful for calculating unknown values in circuits. For instance, if we know the voltage across a resistor and its resistance, we can easily find the current flowing through it.
And vice versa, if we know the current and resistance, we can calculate the voltage drop. But what about Kirchhoff's laws? They seem a bit more complex.
Kirchhoff's laws are essential for analyzing more complex circuits, Alex. The first one, Kirchhoff's current law, KCL, states that the sum of currents entering a junction in a circuit is equal to the sum of currents leaving that junction.
So, it's all about the conservation of charge. What goes in must come out. That makes sense.
Exactly. KCL ensures that charge is conserved at every point in a circuit, which is crucial for maintaining the flow of current. Now, Kirchhoff's voltage law, KVL, is about the conservation of energy.
I remember this one. KVL states that the sum of the voltages around any closed loop in a circuit must equal zero. In other words, the total voltage rise must equal the total voltage drop.
That's right. KVL is based on the principle of energy conservation, which is a fundamental law in physics. It's a powerful tool for analyzing complex circuits with multiple elements.
Speaking of complex circuits, these laws become incredibly valuable when dealing with networks of resistors, capacitors, and inductors. They help us solve for voltages and currents even in intricate setups.
It's fascinating how these simple principles enable us to understand and manipulate complex electrical systems. From a tiny resistor to a complex integrated circuit, these laws hold true.
Indeed, Ram. Whether we're designing power distribution networks or intricate electronic devices, Ohm's law and Kirchhoff's laws remain fundamental tools in our toolkit as electrical engineers.
As demonstrated by Ram and I, voltage and current laws form the bedrock of electrical engineering principles. Ohm's law relates voltage, current, and resistance, while Kirchhoff's laws, both the current law, KCL, and the voltage law, KVL, provide guidelines for analyzing complex circuits and understanding the behavior of current and voltage in various parts of a circuit. These laws are essential tools for engineers working with electrical systems, helping them design, troubleshoot, and innovate across a wide range of applications. For more information, please like, share, subscribe our channel and comment your feedback.